Well, solving simultaneous linear equations by substitution sounds very complicated, but it's actually very easy, guys, and I'll show you how to do it. Now, this is an example. Actually, there's two ways of solving linear simultaneous equations with algebra. That's what this is about. The previous video we used graphs. Now we're going to use the algebra technique. No graphs in sight. And the first of two videos on the algebra, of which this is the first of two, is the method we use called substitution. The other method, which we'll show you in the next video, will be using elimination. Okay, and I need to show you both, and you need to learn how to do them. Okay, so let's go forth and do this with algebra using substitution. Okay, now we've got this equation here, y equals 2x minus 1, and you give it a label, call it equation 1. Then we've got this one here, which is 3x plus 4y equals 29, and we call that equation 2. Now usually you use substitution, guys, when you've got one of these equations is y equals mx plus c form. Like, see, y is the subject, and it's already made into y equals mx plus c form for us. So it's very easy to do the following, right? So you say, oh goodness, y is 2x minus 1. So the problem is that these equations have y and x in them, so it's a bit difficult to solve it for what is x and what is y when you've got two pronumerals floating around in each equation. So you do this ingenious little technique where you say, alright Mr. Y, I know that you're 2x minus 1, so I'm going to put you as 2x minus 1 in this, the other equation from the one where the 2x minus 1 appears as y, as not y, but 2x minus 1. And then you've got an equation in just x's, which you can solve for x. That's the procedure. Once you get an actual number for what x is, then you substitute that number back in either of these equations as that particular number that you found it to be, and then you can find the other one, the y. I'll show you. If that was too complicated, I'll show you. So what we do is we say, from equation 1, I'm going to substitute for y as 2x minus 1 into the other equation, which happens to be equation 2. Alright? Now, therefore, now you look at this. This is equation 2, revisited as 3x plus 4 times, now y was 2x minus 1, wasn't it? Yeah? Okay, and that now equals 29. That's equation 2 with this version of y put in there in terms of x. Now I'm just going to simplify that and go through all the algebra to work it out to solve for x, because I only have one pronumeral to worry about, which is exactly what I want. Okay? There we go. First step is always to multiply out the brackets. So that gets 4 2s are 8. 4 times minus 1 is minus 4. Now I collect my like terms, have a clean up line now. So that gives me 3x add 8x gets me 11x. So now there's my clean up line. Now what have I got to do now? I've got to get the x. Remember what we're trying to do. We're trying to get x. So get rid of this little beastie here off there, I'd say, by adding 4 to both sides, wouldn't you? Yes, so let's do that. Okay, I've added 4 to this side in red, I've added 4 to that side in red. Now, these ones are going to cancel out. Good, and we're going to get a clean-up line happening, because 29 plus 4 is 33, so 11x is 33. One last step. If we divide both sides by 11, what do we get? Yes, we'll get that. That cancels out like that, and you know that 33 over 11 is 3. So therefore, x is 3. See how easy it is? Now we've got it. We've got it where we want it. We know what x is. X was really 3. So we're going to substitute this little beastie back in either of those equations, not as x, but as 3, and then y will be the only unknown, and we can work that out similarly to the way we worked out x, the same algebraic process. Alright, so we're substituting x now as Mr. 3 into equation, it doesn't matter, I've done it into equation 1, because that's probably the easier one of the two to do it in. And we know that 1 reveals to us that y is 2 times 3 minus 1, which is 6 minus 1, which is 5. That's what y is. Okay, guys, we've solved it. Now, that is the answer. That is the answer. Now, the rest of what I'm going to show you on the right-hand side of this screen is just checking whether we haven't made a mistake. And this is not part of the solution. This is just a nice check to give us confidence that we're right. And I suggest that you do this if you have time. So we check the answers by substituting these values we've got, x is 3 and y is 5, into both of the equations to see if the equations work. So equation 1, left-hand side was y, yes? And the right-hand side is, that was 5, wasn't it? Yeah, the right-hand side is 2x minus 1, and x was 3. So that'll be 2 times 3 minus 1, which is 6 minus 1, which is 5. And look, you see, they're both the same. The left-hand side was 5, the right-hand side was 5. Left-hand side equals right-hand side, so that does work. That rule works when x is 3 and y is 5. Now we've got to see whether this rule also works for when x is 3 and y is 5. And if it does, we're laughing because we know that it works simultaneously in both rules. Okay, so equation 2, left-hand side was 3x plus 4y. Put in the values, x is 3 and y is 5, and we get 29. And what was the right-hand side? Oh, look, the right-hand side was 29, so that works as well. So the left-hand side and the right-hand side are equal to each other, so that x is 3 and y is 5 works in equation 2 as well as in equation 1. So it is simultaneously working in both rules, so we're laughing and we know we're right. You see? That's terrific, isn't it? And we're feeling very bright because we're right. Here's another one. We'll do the same thing, exactly the same thing. So what's the first thing do you do? What is the first thing you do? You label them, right? You label them. And then you'll notice that both of these equations here are in y equals mx plus c form, so they lend themselves very well to this technique of substitution. Okay, so what I'm going to do is I'm going to substitute for y in terms of x from this equation into this other equation as follows. Okay, equation 2 will now become not y, well it is y, but it's in terms of this stuff here from equation 1. So y, which is 5x minus 8, is equal to minus 3x plus 16. And look, this is lovely because this equation now only has x's in it, and we can just crunch through the algebra to solve it for x, right? Now, what's the first thing that you would do? I can't remember what the first thing I did was, but you have to get all the x's on one side or the numbers on the other side by using the game of opposites. Yes? Alright, so it looks like I added 3x to both sides to get all my x's on the left-hand side, right? I'll show you. Therefore, 5x plus 3x, right, that's adding 3x to the left-hand side, minus 8 is equal to, okay, minus 3x plus 16. There's the 3x added to this side, there's the 3x added to that side. Why did I do it? Because to make these two beasties cancel out, right? That's effectively moved the x term from the right-hand side here as a plus 3x over to this side. Now we do a clean-up line now. That's 8x minus 8 gets us 16. Okay, now, next strategy. I want x, not any number, okay, on this left-hand side. I've got all the x's on the left-hand side, but I haven't got all the numbers on the right-hand side yet. So I'm going to get rid of him away from there by adding 8 to both sides, the game of opposites, right? Minus 8, we have to add 8. So, there it is. You see, I've added 8 to both sides, there and there. That's going to cancel out, which is exactly what I want. Now, a clean-up line, 8x equals 24. Now, what's the last thing we do, guys? Yes, we divide both sides by 8, right? Now, that's 8 times x. That's what that means, 8 times x divided by 8 equals 24 divided by 8. Let's do the cancelling. That cancels like that. The right-hand side cancels like that. And I'm left with x equals 3, and it fills us with glee, doesn't it? Alright, that's half of it done. Now we've just got to basically substitute this value back into either of those equations to get what y is as an actual number. So I'm substituting, what I've done is I've substituted x equals 3 into the first equation, right? And it becomes y equals 5 times 3 minus 8, right? And that's 15 minus 8. What's 15 minus 8? 7. And we're in heaven, and that's the answer. That is the solution. That is the solution. Now I'll just do all this other stuff just to check that I haven't made a mistake. Right? If I have time, it's a good idea to do this. I always do this to check whether I have made an error or whether I'm right. Okay? So, well, we've got equation 1. Let's see if the equation works with that value of x and that value of y. So, y is 5x minus 8. Let's work out what 5x minus 8 equals if x is 3. That would be 7, right? And what was y, the left-hand side? Left-hand side was y is 7, and the right-hand side we've just worked out to be 7. Which is great, because they both work, see? Left-hand side equals right-hand side. See? Do you understand? 5 times 3 is 15, 15 minus 8 is 7, and y is 7. So left-hand side equals right-hand side. It works fine. Now let's see if it also works in the second equation. Y equals minus 3x plus 16, so let's work out the right-hand side. That's minus 3 times 3. Plus 16 is minus 9 plus 16, which is 7. Now, the left-hand side was y, which was 7. See down here, y is 7. So it looks like left-hand side equals right-hand side. Oh, beautiful. So this solution, this value of x, this value of y, work simultaneously in this equation and in this equation here. Yes? And on a graph, that would be the point of intersection of both those straight line graphs if you did it graphically. So are you getting this now? Are you happy? Do you know what to do? You've got to do some practice to get really good at them, okay? Now, here's our summary. When using the substitution method to solve simultaneous equations, you choose the equation in which one of the variables is the subject, e.g. y equals mx plus c, or even x equals something y plus c will do. It doesn't matter. You know, one of them has to be the subject, you know. So, when you practice them, you'll see what I mean. Now, you substitute this expression in for the variable into the other equation, and you solve, which is what we were doing. And then when you've got an answer for that particular variable, a numerical answer, you then substitute that answer into one of the equations to solve for the other one. And then you check your solution, like I showed you how to do. Yes? And you're a star. So you've got to go now and do lots of practice and help your mathematical thinking by getting good at this stuff, all right? And we'll see you in the next exciting installment, and have a wonderful day.